On November 9th, the astronomical community was once again shaken by two extraordinary images. Both the James Webb Space Telescope and the Virtual Telescope Project released new photographs of 3I Atlas, a name that already struck intrigue among experts and casual stargazers alike. What they saw shocked everyone. A razor-sharp, concentrated point of light, brilliant, but suspiciously tidy. There was none of the dust, gas, or glowing debris that should have marked its journey so near to the sun. In place of an expected glowing tail, nothingness, nothing that would indicate the loss of countless billions of tons of volatile materials. Incredibly, these new images were nearly identical to those snapped back in July by the Hubble Space Telescope. For something subjected to such intense solar radiation, its pristine and static appearance was nothing short of rebuke to everything comet science says should be possible. Some experts dismiss the anomaly, but for leading astrophysicists like Avi Loeb, it was not just an anomaly, but a cosmic prompt to reconsider everything we think we know.
This isn't the first time the universe has presented us with a puzzle, but in this instance, the mystery deepened further with each new piece of data, each reinforcing the sense that we're dealing just not with an outlier, but potentially with a new type of phenomenon altogether. Media, social, and scientific forums buzzed with speculations. Was it a comet, an asteroid, or was it something else entirely, possibly artificial? Most crucially, why did its behavior remain so paradoxically stable under conditions that should, according to every previous observation, be wildly destructive? The tension rose as astronomers continued to analyze the object's behavior near perihelion in late October. Instead of slowing as it barreled through intense solar wind and heat, Atlas inexplicably accelerated. NASA's Jet Propulsion Laboratory announced that Atlas's predicted sky position was off by 4 arcseconds, a discrepancy that, at its current distance, equated to tens of thousands of kilometers. It wasn't a random shudder. Atlas displayed a consistent, directed thrust, causing a calculated sideways drift of over 80 kilometers in just a single month. Such a constant force simply couldn't be explained by turbulent outgassing, meteoroid impacts, or gravitational nudges. If it were venting the vapor required to move like this, the entire solar system would see the resulting spectacle. But instead, it remained isolated and sharp, a deliberate stroke on the black canvas. To make matters even stranger, the pattern persisted through every observation, from powerful earthbound telescopes in Hawaii and Chile to satellites in orbit. Traditional comet behavior had vanished entirely, replaced by mysterious regularity. The silence from instruments designed to detect particulate debris and vapor was deafening. If there was outgassing, it was perfectly invisible, which, by all known physics, is an impossibility. In the months that followed, debates raged. University physics and astronomy departments everywhere began poring over the numbers, running new models and checking old assumptions. For many, the slow realization dawned. This object was not following the rules for a reason.
For further clarity, researchers conducted direct comparisons. The Virtual Telescope Project published back-to-back images of 3I Atlas and Comet Lemon, another visitor passing near the Sun during the same period. Comet Lemon blazed, streaming a classic solar-cooked tail that glowed and curved as it raced along. But Atlas was the anti-comet, pinpoint, steady, refusing to blur or show any signs of surface loss. It was as if it had been etched onto the sky, immune to the forces shaping its supposed kin. Scientists ran the numbers again. If Atlas's acceleration had been caused by lost mass, a gigantic cloud should have trailed behind it, outshining the full moon and making Atlas one of the most spectacular sights in the sky. Instead, it was eerily still, almost like a spacecraft under silent power, not a crumbling ball of ice and dust.
The greatest minds in physics and engineering began to question long-held dogmas. The calculations suggested intent, not chaos. The accelerations were smooth and consistent, aligned almost exactly with the sun's gravitative influence. Suddenly, Atlas didn't look anomalous. It looked organized.
Meanwhile, new international teams joined the search, bringing advanced spectrometers and analytical software. French and German observatories picked up the same readings as Harvard and MIT, the data reproducible and sound. The global scientific village watched as Atlas redefined what a natural object could do, and perhaps what it meant to exist in our corner of the cosmos. If intent was at play, whose intent was it? What force, artificial, natural, or some unknown hybrid, was orchestrating this cosmic spectacle?
Part 4. Blueprint or coincidence? In deepening the investigation, scientists mapped the trajectory of Atlas. What they found was extraordinary. The object's orbit hugged the ecliptic plane within a slim 5-degree margin, echoing the same celestial dance as Earth, Mars, and Venus. Such alignment was not only improbable, it was intentional looking, a galactic maneuver rather than a mere fluke. Then, in another twist, observers saw a sudden jet of material shoot not away from, but toward the sun. According to all conventional wisdom, this was backwards. A comet's tail should always stream away, pushed by solar wind pressure. Atlas, instead, looked as though it was using the sun for fuel, not fighting against it. Spectroscopic scans by both James Webb and ground instruments further muddled the picture. Atlas's metals were not chaotically mixed, but precisely balanced. The nickel-to-iron ratio matched that of engineered metals back on Earth, sparingly used in aerospace applications for maximum strength and heat endurance. Even more bizarre, the body's water content was strikingly low, just 4%. Instead of appearing as a dirty snowball, Atlas began to resemble something polished, built for endurance, and covered in a possible high-tech shell, perhaps a composite or ceramic, that perfectly reflects heat and light. The object's ability to polarize reflected light with near mathematical regularity led some to speculate it could be a probe, built to last longer than any memory or civilization that launched it.
The orbit became even more suspicious when researchers realized that Atlas's path intersected those of Mars, Venus, and Jupiter, but never approached Earth directly. Particularly during perihelion, the prime window for observation, it slipped behind the sun, beyond reach and scrutiny. It wasn't just random. The universe looked as if it had orchestrated a cosmic disappearing act. Called deliberate navigation by some, this dance recalled the famed WOW signal from 1977. When plotted backward, Atlas's projected origin point lay in the same celestial real estate SETI researchers have chased for decades. Atlas now appeared less an interloper and more a chess piece moved with ancient hands. Its surface burned a deep, wild blue, hotter than the sun's visible surface. Infrared analyses baffled experts as it radiated no detectable heat. Its glow was self-made, as if powered by plasma or some unimagined ion drive. Was this object using the solar wind as an energy source, or simply running on the vestiges of technologies billions of years old? Certain plasma physicists posed that Atlas could have an electromagnetic propulsion system, something humanity is just beginning to conceptualize, while others wondered if it was simply a mechanical survivor, still following programming after its origin had faded into myth. Now, a new race has begun. On December 19, 2025, Atlas will swing close to Earth, 167 million miles away, but near enough for Hubble, Webb, and a host of ground telescopes to make their most complete study yet. This upcoming encounter is, for many, the critical test. Will Atlas finally show its hand by venting a comet's requisite clouds of gas, or instead remain an inscrutable, flawless point of light,
collapsing the comet paradigm once and for all. For now, speculation runs wild. Is it a smart probe, a sleeper observer reawakened by our growing technological presence, or simply an alien relic on a never-ending loop? This debate has reignited age-old questions not just about our universe, but about our past as a species. Some anthropologists and historians are reviewing ancient texts, wondering, could legends of fiery chariots or gods descending from the stars be cryptic accounts of similar cosmic encounters? Rock carvings in the Nile Valley, petroglyphs in South America, and megalithic alignments across Eurasia are being re-examined with fresh eyes. If our ancestors saw, recorded, or even interacted with objects like Atlas, what did they take from these encounters? And what warnings or wisdom might still be waiting for us in myth and symbol? Scientists and artists alike now ask, is Three-Eye Atlas a remnant of the same cosmic story our ancestors once glimpsed? Or is it a messenger, arriving just as humanity stands at the threshold of deep space exploration, carrying secrets intended for any species able to recognize the signs? As excitement grows, so does secrecy. Governments responding to new telescope data have begun quiet resource reallocations, protecting observatory data and issuing rare airspace restrictions around key facilities. International collaborations, while expanding, are suddenly fraught with restrictions. Data that was once publicly available is now closely guarded. Meanwhile, rumors swirl about military and civilian teams dispatched to monitor electromagnetic activity on the ground as Atlas passes. Has humanity finally found something that makes its institutions more nervous than war or climate change? Simultaneously, scientists, journalists, and everyday enthusiasts debate fiercely in public forums. Is this a landmark discovery or a rush of cosmic misunderstanding? Should the world be preparing for contact or for more disappointment? Some decry the mounting secrecy, demanding that the skies remain open for all. Others urge caution, aware that the answers we seek could fundamentally upend civilization's sense of place. As December draws near, the world's attention centers on a single point of light, waiting for it to either confirm or disprove everything we know about our place in the universe. Societies rally in anticipation, from school classrooms holding space-watching nights to professional observatories working around the clock. The scientific process, once slow and tentative, now unfolds at breakneck speed. Every hour brings new images, spectral readings, and columns of numbers to pore over. The Atlas test, as it's now called, is the closest humanity has come to a public, global experiment in real time. Is this the centuries-awaited answer to our question, are we alone? No matter what is found in December, one thing is clear. The mystery of Three-Eye Atlas has already forced science, culture, and society to face a new cosmic landscape. It challenges us to be humble, vigilant, and above all, ready to listen when the universe, and perhaps someone or something far older, finally speaks.